Thank you everybody for having me here. I owe this visit to Chris Ford, who I met on a platform at a conference in Taiwan a few months ago. And we seem to think that there might be something in the possibility that the work we do with system dynamics could contribute to improving and upgrading the way in which enterprise architectures are developed and improve their impact as well. So before I get started on the meat of this, let's get a few terms clear first of all. The underlying science, the method behind what I'm going to talk about this afternoon is called system dynamics. It was developed at MIT in the 1960s by Professor Jay Forrester, whose other claim to fame is that he holds the world patent for computer core memory. So he's a pretty smart guy, and he came up with this method way back then, and it basically applies engineering control theory to social systems. He was asked to help digital equipment at the time with some business issues, and he said, well, those business issues are just like engineering issues. Why don't we apply the same tools that we would to that? And the method is useful kind of all over the place. You'll find it being applied in all the domains I've listed there, and some more. So you may be wondering why you've never heard of it. Can I just check? Who has heard of system dynamics? That's more than the usual proportion of people who answer yes to that question. It's a really well-kept secret, actually. And part of what I'm trying to do is bring it out from the shadows and put it in the daylight where it belongs. You will hear the phrase business dynamics. There's a book called Business Dynamics by John Sturman, who's a protege of Jay Forrester. And that's the use of system dynamics for business issues. And the term I'm going to use, and have been using for some time, is strategy dynamics, because I'm a strategy person by background. I was a strategy professional for 15 years. I taught strategy at London Business School for 20 years. And that's the world I come from. And strategy needs system dynamics the same way IS planning and strategy needs system dynamics as well. So, having talked this through with Chris and one or two other people who are much more familiar with the enterprise architecture field than me, it seems that although the two are different, there is a relationship between them. And the nature of the relationship seems to be this. I'm also a kind of what's really going on here kind of guy. I want to understand what's going on under the hood. And the contrast and complementarity between the two seems to be this, that enterprise architecture concerns itself with how processes act on the things and the stuff that make up an enterprise. What do I mean by things and stuff? I mean customers, I mean products, I mean capacity, I mean cash, the things and the stuff of the enterprise. And looking through all the enterprise architecture things that I've been looking at over the last few months, it seems to me that you guys have to struggle with what I've had to struggle with as well, and that is that you're trying to serve a top management community who themselves are poorly supported by understanding of strategy. The strategy tools available aren't good enough, frankly. And you need better strategy tools from the strategy field, and I need better strategy tools from the strategy field. And system dynamics could be a part of that. And the contrast is that system dynamics concerns itself with what happens to the things and the stuff. What happens to it? How do customers get won? How do customers get retained? How do products get delivered? How does the staff get hired? How do skills get enhanced? How do capabilities get built? And it's those that drive performance. And the little thing at the bottom there is really important. System dynamics is a quantified over time method. We build quantified working models of enterprises, of issues, of initiatives. That's what the method is for. System dynamics has no meaning outside the context of time passing. So I've had a look through a number of enterprise architecture sources, and obviously I felt for today's audience I needed to have a little look through TOGAF. And I can see two main places where system dynamics might connect with the TOGAF process. In the ADM stage of the work, clause 8 says a business architecture is what you need, and a business architecture is a prerequisite for work in any other domain of the TOGAF process. And crucially, it says process models describe the functions associated with the enterprise's business activities. So there's hook number 1. Hook number 2 comes rather later when you get on to part 4 with the architecture content framework. And there, clause 36 says you need to carry out a capability assessment. What is the capability level of the enterprise as a whole, and where does the enterprise wish to raise capability? Now, capability is another of these wonderful, all-encompassing words that is thrown around with gay abandon by all kinds of people, particularly the people I work with in the strategy field. But we have to be very clear what we mean by capability. And having a look at the terminology that you use in TOGAF, I think it's pretty close to the terminology I use as well. And I've put quite a lot of effort into defining that term properly so that we can actually work with it and use it. So what I'm going to try to show you is that processes and capabilities fit. They are already implicitly, if not explicitly, part of the system dynamics models we build of enterprises. I'm going to do that by taking you through an example. It's a simple, small, but quite fast-growing business. And what this business is, it's a marine engineering business. It's a division, it's a small division of a larger marine engineering company. And they produce equipment for cleaning the ballast water in ships. Now, they've been cleaning out the oil and the yuck out of ballast water in ships for a long time. Basically, ballast water, when a ship gets rid of its cargo, it rises up in the water. If you didn't weigh it down, it would fall over, right? So you put ballast water in the bottom of the ship to stop it falling over. Then when you put the cargo in, you've got to take the ballast water out. And because there is the risk that when ships move from one part of the world to another, they take biological organisms with them and spread those biological organisms to places on the planet where they don't belong. So the International Maritime Organization is on the very point right now of introducing regulations to require the biological cleaning of this water. There are 3 technologies. One is a kind of physical process where you get the little bugs to clump together and then you suck them out with magnets. The second is a kind of grown-up version of how you clean a swimming pool, where you treat it with chlorine. And the company I'm talking with here uses a combination of filtration and ultraviolet treatment to kill the bugs. That's how it goes about doing the job. And here's the world in which this company is operating. There are something like 50 suppliers of this equipment, even though it's not actually required by anybody yet. You know, every marine engineering in the company in the racing to come up with good technology for this problem. 35 approved systems already. It won't stay like that. There will be losers in this. This is going to be an intensely competitive battle. And the reason it's going to be intensely competitive is that the regulations will require all the vessels in the world to be fitted with this equipment in their next dry dock visit for routine maintenance, which they have to do once every 5 years. So basically, over 5 years, 57,000 vessels are going to have to be fitted with this kit. So it's rather important that you win, or at least don't lose in this competitive race. So the challenge for this company and the others is how to capture the ship operators' decisions on which system to deploy and achieve rapid installation in their fleets. You know, you want to capture a ship operator who's got 200 vessels, and then you quickly want to capture the order to get your equipment installed in those 200 vessels, which will be done in sequence. So this is the kind of top-level control panel of the working quantified model of this business and its business plan. And you might just make out down here, this is the income statement with revenue, cost of goods. The green is the cash operating expenses, and the purple there is the EBITDA profit, earnings before interest, tax and depreciation. But those dotted lines there, those are the actual numbers of the business. And what we do with these models is, you know, we try to get pretty close to what history has actually done. It's no good coming along with a model that is supposed to be about a business and it can't even replicate what's actually been happening. That's not a good start at all. There are also some dotted lines here on the company's sales. And this is the planned increase in the number of models of equipment. They've currently got one model of equipment that is suited to medium, small type vessels, kind of fishing vessels, oil field support vessels, small ferries, that kind of thing. And they have plans to raise that number of vessels. This is going over 5 years. And what the board wants to know is they want to know what's going to happen to cash flow. Here's the historical cash flow. Here is the modelled cash flow that they hope to get out of this business. So that's a kind of top level view. And what does the model itself actually look like? Well, you get inside and you peer at a piece of the model, and this piece is about the installation of vessels. So we've had the equipment made to fit this vessel. It's sitting there waiting, and we now go and install it in the vessels. And when it's installed, we get paid when it's installed, or at least a few months after, and we continue to get revenue for maintenance and spares after the equipment's been installed. So what the models do is they capture the interdependencies. This installation rate depends on, is the equipment there? And if it is, have we got enough service engineers to fit it? So this thing is the minimum of those two things. And every object that you look at here is a relationship. It's a causal relationship between usually physical things. So this one here is the maximum projects that can be delivered per month, which is the number of service engineers multiplied by how many installations each person can do each month. So there's nothing mysterious or mystical about this. This is basic. I wouldn't even call it maths. This is basic arithmetic. And these equations we write, that is the equation. It's not like Excel, kind of $32 multiplied by worksheet $3 $28. It's service engineers multiplied by maximum projects per person. That's the equation. There's nothing else going on. So a way to think about this. The other thing is that we deal with these things. These are called accumulations. They're stocks of stuff. And a stock of stuff that you would be very familiar with would be the stock of data that a company has. We have stocks of cash, we have stocks of people, we have stocks of inventory. So the method deals explicitly with these accumulations. And the way to think about this is think of each item here as being a column in a spreadsheet, and that label there, that's the label at the top of the column. And that relationship is the equation that runs down all of the rows in the spreadsheet. So in theory, you could build one of these in Excel. You'd be absolutely mad to try, but in theoretical terms, it ought to be possible. And the reason you couldn't do it is because the human mind can't get their head around the whole architecture. And what the method does that I'm going to show you is the method puts together the architecture logical step by logical step, starting with the thing you want to explain, what's going to happen to cash flow, working back through the stocks of things that drive that. So sales drive revenue, engineers drive staff costs, and so on, until you've actually captured the whole thing. So don't panic for a moment. This is the model. And that's the piece I just showed you. Right? So I've just given you a summary of that little piece here. But this is the whole of the business model. There isn't anything else. And these are the pieces of it. Up at the top left there, we've got the R&D we spend. We contract out the R&D. The R&D gets new models into development, and when they've been developed, they get passed to the US Coast Guard and the International Maritime Organization for approval. Right? So R&D to develop the models, that is a process that has to happen. Getting approval by the authorities is another process that has to happen. So we've got a couple of processes up here already. The next piece over to the right, the green block in the middle there, that's the sales force. So this is hiring salespeople here, and that's the little stock of salespeople increasing over the company's business plan. And all these things down here allocate that sales effort to the different things that salespeople have to do. So the allocation of sales effort is a process that this company has to do well. Should I send my salespeople to see agents? Should I send them to see new prospects? Should I send them to sell additional installations to customers we've already got? How do I make that decision? The next section down is about agents. So this is a small company. It has not got hundreds of sales reps on the road. It deals with agents in different parts of the world, and the agents do most of the job of bringing customer prospects to their attention. And when they do that, we have the blue section here. This is potential customers, and this is actual customers. So every time we launch a new model, we give ourselves access to more possible customers, and our salespeople and our agents turn those possible customers into actual customers. You know, the customer says, yes, I will buy a piece of your equipment to try in one of my vessels. The next piece down is that when you've got customers, the customers bring their vessels. So this is all the vessels that all of these customers have got, and our sales effort sells projects into that fleet. The projects get built in a sequence, and they then get completed, and they're ready to be installed in the vessels. So projects are managed by project engineers, and installation is managed by service engineers. That's what I just said. And next to that, we've now got to get to the really interesting stuff as far as the CFO is concerned, which is how do we make money out of this? Well, we make money because the installation process drives revenue, and these staff and these staff and these staff drive costs plus the R&D that we're investing up there. This is the income statement. This is revenue, cost of goods, and down here we've got the EBITDA profit. So that summary stuff up there is simply copies of data from elsewhere around that. This is the working model. This is what we do for the CEO of this business. We build a model of how the business plan is supposed to play out, and then we see how different will it be if we make some different decisions. So if I just run this with the baseline decisions, kind of nothing much happens here. The only thing that happens is that we develop more models here, but we're not selling them because we haven't got any salespeople on the task, and we aren't installing them because we haven't got any engineers out there. So let's put a few more salespeople in there. Let's put a few project engineers on the case, and let's maybe put a few more service engineers on it. And what's going to happen from there? Well, actually, we start now, and we're getting some sales and we're getting some profits. And that sawtooth thing there, that's not a mistake. That's happening because part of the system is under-resourced. What's happening is that the vessels, the equipment's being developed, and it's ready to be installed, but they haven't got the capacity to install it. So only when that capacity gets free does the installation actually happen. So you get, oh, we can install one this month, but actually we can't install one next month. Oh, we can install one this month. Oh, we can't install one next month, which is a real risk for this business. So we can explore all kinds of different strategies and scenarios here. You may have spotted, I whizzed past it, that we have the price of the equipment in the model, and we've got competitors' price. We can look at the sensitivity of the business plan to relative price compared with our competitors. We can look at the sensitivity of the business plan to the relative performance of our equipment relative to the competitor. Our equipment can push through 100 cubic meters an hour. Their equipment can only push through 80 cubic meters per hour. What difference does that make to our ability to grow sales and profits? So that's just an example of what one of these things is. I thought it was going to be rather difficult to have a conversation with you about the possible complementarity between system dynamics and enterprise architecture if you didn't have some idea of what a system dynamics model is. Well, that's one. So what is system dynamics? It's the use of quantified causal diagrams and simulation models to understand and manage complex systems featuring stock accumulation and feedback. And the little parenthesis there is really important. This is not a question of people waving their arms and saying what they think causes what. There is rock solid theory underneath these. Every time we build one of these models, we are building a theory of how the enterprise works. And we're validating that theory by checking it against how the business actually performs. If we fail that test, our model's no good. All right? So you can have confidence that there's something pretty solid going on. And we can disaggregate this to any level you like. we could build a more detailed model of the sales process. We could build a more detailed model of the project process. Indeed, we don't always build models of the whole enterprise at all. I do quite a lot of work in the pharmaceutical sector where the main issue they're concerned about is the competitive episodes that happen when a drug runs off patent and generic drugs come in and try to take over the sales of that drug. So that's an issue-focused, a function-focused model. It doesn't even try to model the whole pharmaceutical enterprise. That's not what it's for. But that question is really important, and it's really important that you figure out how to answer it. Now, I don't want to oversell this. System dynamics has been seen to be complicated, difficult, technical for as long as it's been around, really. It's kind of 40 or 50 years. I don't want to pretend it's easy, but it is perfectly doable. It is a professional thing that people are able to learn how to do. And when you can do it, it can do things really, really fast. That model that I just showed you for the ballast water company, I built during two-hour Skype calls with the CEO over 2 days. That's how long it took to put that model together. And it's not because I'm some kind of genius kind of guy. I followed the procedure. There's a procedure for doing this right. If you follow the procedure, you get an accurate working model, and it's pretty unambiguous, and it's pretty defensible against any challenges. Furthermore, we have some pretty standard architectures. We know what businesses of different types actually look like. I just showed you a marine engineering business that builds a kind of equipment. That would be transferable to all other 50 suppliers in the industry. It's the same architecture. The numbers are all different. The nature of the equations in the structure are all different, but the structure itself is essentially the same. We can do an awful lot with this. We can take standard models and modify them and adapt them. There may be things you want to take away. There may be things you want to add in. This particular business outsources its R&D, for example. Well, another business that does not outsource its R&D, has the R&D itself in-house, you'd put that in the model. There's one or two links here that I'll include as we go through, but there's a little link here to an article about what this process actually is. And I'm afraid I've been a bit cheeky and I've stolen the agile word from your world. The reason for that is that the traditional approach to building system dynamics models is uncannily similar to the waterfall method for IT development. And it takes too long, costs too much, and it's not very reliable. So this process costs less, doesn't take so long, and I think is more reliable. So that's just a little explanation for the method there. So I said earlier on that I think the hook here for enterprise architecture consists of two words, processes and capabilities. So where are capabilities in this model? Well, here is a capability to take on customers. When a customer says yes, there are things that have to be done to take the customer on and build them into your system so you deal with them properly. Taking on those new customers, selling to them and taking them on, it is a capability. Selling new projects, specifying those projects, managing the projects so that the equipment is delivered on time, managing the installation, managing the support for the equipment, managing the spares provision. Those are all things you have to be good at. And what do we mean by good at? They have to happen quickly, reliably, and at low cost. Which I think is pretty similar to the way you guys think about capability. We have to be good at hiring engineers, we have to be good at paying engineers. So where in my models does a capability feature? Well, the effectiveness of each capability determines the equation. That's what it does. It determines the equation. A more capable organization at specifying projects will specify projects more quickly and will allow that pipeline to happen slightly faster. Right? So what we can do is we can go back to our model and we can say, well, let's have a look at what would happen if we weren't quite so capable at project management. So this scenario assumes a project management of 1. We are as good at managing these projects as it's possible to be. What if that capability was only 0.8, 80%? Well, yeah, we're not far off. We haven't made that much of a difference here to the install base. Sales are pretty close to what they were, and down here the revenue grows nearly as far. We run into this kind of mismatch of capacity a little bit earlier, and our profits are a little bit lower. So, maybe 50% capability isn't too bad. What if it was only 50%? We're really not so good at this. Well, if it's only 50%, oh dear, we're now in trouble, right? We're not achieving the sales, we're not getting the revenue growth, and our profits, in fact, we're barely being profitable at all. Right? So we can assess exactly what happens if capabilities differ by well-specified amounts. In my language, what does capability give us? It gives us speed, how quickly is the task done. It gives us quality, how well is it done. When that equipment is delivered, is it reliable? Or are there some faults with it that mean it won't perform as well? And it gives us cost. So at how low a cost can this activity be done? Quite often linked to speed. And the next hook is that inside each capability, there are processes. We are good at doing this thing because we do this process and this process and this process really well. But in order to have the capability, you've got to have more than just the processes. You need enough people, you need people with the skills, and those people need access to the information to help them do that. So there's the second hook. So let's just have a little peer inside this capability thing and see exactly what's going on there. And I'm going to take a slightly simpler case, and this is a customer support business. Think of this as something like claims handling in an insurance company, for example. Up at the top, we've got customers. This is a snapshot of a working model running over 24 months. And I'll give you the link to the model afterwards. You can just go and run it in your browser. You don't need to install anything. We've got a number of customers who are making incoming calls, and the maximum calls that our department can handle is less than the number of calls coming in. So we've got an overload, and the overload means that some of those calls aren't handled very well, and we lose some customers. So things are not going too well here. We've got 60 staff, and we are winning and losing about 3 per month. So the staff base is the same. So there's the staff. What's the maximum calls that those people could handle if they had all the processes, all the data, and all the skills they need? Well, they could handle 4 times the rate of calls. That seems like a very large ratio, but they could, because we haven't got people who are entirely skilled. The average number of skills these people have is 15 out of 30. We define what the skills are, and we train the skills in, and we check those skills against that catalogue. We do training to build the skills up. We put extra time into each call to ask the call handler to help complete the missing data. We've only got 75% of the data. We've only codified 20 out of 70 procedures. That might seem a very small fraction, but as you know, you don't codify everything because some things you do so rarely, it simply isn't worth the investment of effort to do it. And what do we mean here by a procedure? Well, it's the kind of stuff you do in your process, flowchart things. Call comes in, hear the request, check it with the data, resolve it, and end the call. Now, this is what you can do with this working model. That's what happens to the time per call, given nothing being improved here. This scenario is one in which we start adding procedures to our procedure base. We seek out more data, we raise the training, and then we add more procedures. So we gradually drive the call time down towards the minimum that's possible. And this, again, is a working system dynamics simulation. That's an operational capability which is not to be underestimated. We've heard this morning the importance of some operational capabilities. But the bigger items here are strategic capabilities, by which I mean the building of those major resources, the winning of customers, the development of products, the development of people. And for this, I'm going to use another different example. This is a retail store chain for whom the expansion of the store network is the critical capability. We've got a certain number of stores. There is a massive potential. We've only scratched the surface of this opportunity, and we're currently opening stores rather slowly. And it takes us 30 months to open a new store, and we reckon that if we were as good at it as we possibly could be, it could be as little as 15 to 18 months. we don't pick very good locations, and it costs us more than it should. So there's our three capabilities: speed, quality, cost. And here is the result of another working model, and this is the store growth trajectory over the last 3 years of a 5-year plan. And this is the stores actually coming online, and here's what happens to the profit growth under those two different scenarios. And this organisation is learning to open stores faster, better, cheaper. And there's a process for opening a store as well. There's actually several stages to that process. So where does the dynamic model contribute to the ADM? Well, it's really pretty early on. It makes some contributions when you're defining the scope of the enterprise architecture. It could help when you're specifying performance improvements. The real core, though, is it gives you a rigorous, quantified, working model, a rock-solid platform of how the enterprise actually functions at that stage B. And it seems to me, this is your world, not mine, but it seems to me, if you get that wrong, all this is going to be in trouble. All this is going to be in trouble. If you're doing all your IT architecture to support something which is underspecified or inaccurate in some way, your EA is always going to be struggling. Just a little parenthesis here, we can also build models of any functional plans as well, including plans for IS. So how might SD enhance enterprise architecture efforts? Well, we can help possibly reduce the ambiguity about how the enterprise works. We can raise the certainty about the prospective performance. I'm doing another piece of work for the International Integrated Reporting Council, which is concerned that we don't understand enough about firms' prospective performance. This is a kind of investment analyst challenge. I'm not saying we can make it 100% certain, that's way beyond what we could achieve, but we can certainly improve the certainty. We can generate quantified working scenarios. Somewhere in your TOGAF process, you have to do some scenario planning, right? Well, our scenarios are working quantified scenarios. They're not just descriptive. We can do it iteratively, we can do it at any level you like. Whole enterprise, business unit, function. Then we can specify, quantify, and locate every process and every capability in the working system. We know how the system works, we know exactly where these things are, and model their impact on performance, both business as usual and improved. So, this is where I have to be really careful. This is your world rather than mine, right? I don't want to overpromise, and I don't want to overclaim. So these are genuinely questions for you to think about and for us to have a dialogue about. Is it possible, though, to use system dynamics to make enterprise architectures substantially more powerful in supporting the work that you guys do and supporting the way in which you support senior management to run the business? Is it possible to sharpen the skill involved in building enterprise architectures? Your Clause 8 is a pretty big ask, actually. Part 2 of your TOGAF process is a pretty tall thing to ask anyone to build the skills to do. Maybe this would sharpen that skill and that capability. And it's certainly teachable, right? We can teach people how to do this. Could it be possible that we could enhance the enterprise architecture software? I don't know exactly what Archimate does. Does Archimate build working quantified models? Maybe we can raise user confidence. I don't know how easy you guys find it to persuade senior management to embark on this enterprise architecture thing. It looks like a pretty huge investment that you're asking people to make. Is it possible that you could improve their confidence, raise their confidence in the process, raise their confidence in the professionals who are doing it, and most importantly, raise their confidence in the result? This is an enterprise architecture that we can demonstrate actually does work. It replicates what your business actually does. So maybe it's possible to raise user confidence. And this is perhaps paradoxical, but if you can do things more effectively, not only may they be done better, but we can actually do this faster and at lower cost. Seems to me like the TOGAF process is a pretty large amount of work for a pretty large number of people to do all that. Can we shave some time off that and actually get it done faster and cheaper. And then turn the enterprise architecture into a truly living tool. You know, you can run this model anytime you like. You know, next Tuesday, next month. You know, bring it out. You know, you've got an idea for doing something different in your in your IS project portfolio. Well, let's go and tweak the model and see how differently the thing plays out. No idea what the answer to those questions is, and I think the only way we're going to find out is to try it. So if anyone fancies having a go at trying it and would like to talk about that, I'll be happy to talk to you about that. Yeah, those are the links to the things I've been talking about.